Okay, great. So let us try to revise what we did yesterday, so that we can refresh our memory and then go ahead. So in the first class, this is the picture that you need to have in your mind. So all through your programming journey, that this is your basic um, ingredients, and then we're trying to play around with that. I'm not going to go deep. And then this is something which you need to keep in mind. Python code gets converted to bytecode, and then there is an interpreter which translates it to machine code. That is called as a virtual machine or the interpreter. And yesterday we saw uh, why data types exist, and I gave a comparison between C, C++, and then uh, uh, the Python. Python has this many data types, and just remember that Python is completely object-oriented programming, which means that, for example, in Java, you can have inbuilt or primitive data types like integer and character and float, like that. But in Python, even those numbers, integer, float, all these are objects. So that is what we tried to do yesterday using dir, and um, uh, there was another function type to find its type, and things like that. We looked at strings. Strings are nothing but the usual uh, list of characters, and you can imagine something like necklace, something, and any of such examples, real world examples. This is to help you to understand that it is not mutable. You cannot take out one single item from out of this, right, in necklace. So that's the idea. It is not mutable, it is read only. And then we saw the list. This is actually mutable, which means you can actually play around with, remove an item from middle or anything like that using certain functions. Like yesterday we saw remove. And tuple is exactly like list in terms of arranging the elements, but it is read only. So you can use tuple whenever you deal with databases, longitude and latitude, which is GPS location and things like that. And set, yesterday we saw why do we have set. It looks like it has flower braces when you look at it, but it supports operations which are faster, especially for the search. Searching is very fast in set. And one thing you need to keep in mind is how does this work in the backend is using something called as hashing, uh, wherein you send a number, you operate on certain hash function, and then you get a number, which is again then translated to the memory location of that particular element. So that is called as hashing. So um, it's a semester concept in engineering, but yeah, that's how it works. So dictionary, you can, if you just remember the railway station, you will have almost all the data types that you want to remember. Like for example, set is a ticket where you cannot change, and then string, you can say sitting together in a on a seat, and then dictionary, you can uh, imagine cloakroom and things like that. So that is something which you can remember. And underlying concept of all this is this one, which is RAM. RAM is something like this grid. So we are trying to play around with RAM. So for example, if you're trying to play around with, if you have initialized a list, that means we are trying to access contiguous memory. Key value pair, probably it is like key 1 is stored here and value is stored somewhere else, and probably key 2 is here, value is somewhere else. And the hashing function, which is some function, it will take an element and translate that into the memory location of this, and probably key and value. Let me write it like this. and it will translate to that particular memory address, and you get that value out of it. So that is how the searching is faster. So if you're using any sort of search intensive application, use dictionaries. If it doesn't have key and value, sometimes you don't have key and values. You just have some list of lot of numbers or strings or anything like that. So in such cases, use set. The underlying logic in set and dictionary are the same. It's dictionary just has the key built into that. So that's about the data types. And then let us look at, and you can and you also have to remember that we shouldn't use any of the inbuilt um, keywords in variables. So I will show you what happens in meanwhile. So you'll get acquainted with this and get used to this. So you won't be using it, and also your ID won't allow you to. It will warn you once you start using it. Okay. So yesterday I wanted to discuss something about if else statements. So if else and for loop. So these are the basic elements where you can control the program flow. For example, I'll go back to ID. For example, we have some number for x is equal to 2. Okay. And then I'll print x. And I can do a lot of things here, like initialize y to something and keep on writing program, right? So if you just write this kind of program, we won't have control. What interpreter or the compiler does in C++, it's just reads through all this. And when you try to execute, it just executes line by line. So how do we control? For example, I want to check for x. So some value and then do some action. If x is equal to 2, then do something. X is 2, something like this. And then if it is not, so x is not 2, something like that. Okay. This is a very basic trivial example. So if you execute it, so you can see that this if condition is there, and then you can see that this also gets printed. That is because we have to understand the scopes and the indentation. So how other languages work is like this. Let me annotate. So in all the other languages like C, C++, the language previous to that. So how compilers would understand is not like Python. So how we would understand is, for example, if I have to write it in C, so I would write something like this. And I would initialize, tell the compiler that this is an integer, and then x is initialized to 2. And then I have a semicolon. So this tells the computer that, okay, this is an integer, that is, I need 32 bits if it's a 32-bit compiler. 32-bit, I need 32-bit, and then this is the ending of the statement. And then how do you initialize or how do you write if else conditions is something like if some condition, and then you would write braces like this. So when you, it is only for humans that we write in this format, like if and there is new lines, and then you end with and like this. In fact, you can write it like this as well in one single line. Entire program of C++ can be written in one single line. And you can also look at, there is actually a competition in C, C++, and I think even in Java, something called as obfuscated code, wherein you try to write code in such a way that it doesn't look organized. I'll just show you just for knowledge. So I have another monitor here. So. snippet. So this is how Python is different from, you can write C programs like this, and compiler will take this and compile this to a single line, remove all everything, and then, so this is how you can write anything like this, because it works on basis of um, these semicolons and these braces. But in Python, it's not like that. In Python, you can see that we have indentations like this. So indentations, I mean, for example, in line number 4, once I start with if condition, there is some sort of space or tab here. So this is how the interpreter in Python comes to know that, okay, this is a different scope. This is like a story. Like you have a big chapter and then you have sub chapters. So this is a sub chapter for program execution. So that is how the uh, Python interpreter comes to know that, okay, uh, this is a new section in the program. So you'll get used to this. This is a very basic thing.
That means after the pipeline, we need to have space.
Correct. With a new
Pipeline.
space
Yeah.
or tab. Yeah.
Oh, okay. Yeah.
So yeah. So general convention is that you do not use tabs. Of course, tabs work, and use 3 spaces. It's just a recommendation, but it's not actually. Nobody is stopping you if you use 1 space or 2 space. Like this is 1 space, and it still works. But the problem is, once you start using 1 space, always use example, this works. This doesn't work. It says indentation error. So this is because this is not followed by any of the control functions. Control functions, in the sense, if, else, for loop, while loop, and things like that. So if, else, and just remember, we do not use while loop much in Python, although it is supported. Just remember if, else, else if, and then for loop. So these are control keywords. So yeah, so this is about indentation. So how the compiler or the interpreter knows that this is a different section of the code and I have to run towards this. Okay, in fact, we humans use it every day, right? For example, okay, if it is 7 o'clock, I have to join the class. So something like that. If you want to write it, it's like if x is equal to 7, attend class, and soon after the timer is over, you exit the class. So this is natural for us, but we need to train our minds to think in that terms. Programming is thinking step by step and thinking clearly. So this helps us to think in a methodical way. So that is about if condition. So if is keyword. So whatever expressions that you give here, for example, x is equal to 2 was an expression. So it evaluates to either true or false. If that particular condition is true, it executes the statements and underneath it, or else it doesn't. So expressions, for example, one of the common mistakes that we do is, for example, if you want to check whether x is equal to 2, sometimes we write it like this. Your ID is intelligent enough to say that this is syntax error. So this is a function from the IDE, but if you try to write it in a plain notepad or command line on Linux, so this won't get highlighted. So this is a common mistake. So this equal to is different with this equal to. This is an assignment operator, which is like I'm assigning 2 to x. Here I'm checking whether x is equal to 2. So just remember this. I think it's there in all the languages. So that is about if condition. And similarly, there is a corresponding else condition. Let me bring it back. So I do not want this to get printed because I want it in the else clause. I can also write else do this. Let me correct this. So we use four spaces. You can see four dots here. So on ID, it sort of gives us a hint that it's space. So when you execute this, you don't we have 7 here. Let me put it back to 2. And you can see that only this gets printed. That is because this is false. It checks whether x is equal to 2. Yes, of course it is. And then it goes to this condition else, which is and then it does. So if I change it to x is equal to 4, this doesn't get hit because this section of the code gets hit only if hits this condition. So that is about simple if else condition. There is also something called as elif. You can it's if you have multiple conditions, for example, if if x is say divisible or if x is a even number, print even. So let us see if this gets printed. If it doesn't, let us understand why it doesn't get printed. So it just it checks this condition. Let me put it back to true. It checks this condition. Of course, it is 2. It prints, and whether we are checking whether x is an even number. So this is a way to this is a modulo operator. If you use any number modulo 2, it will evaluate to 0, which tells us it is a which gives us a reminder basically. So it tells us it is an even number. So it is not getting printed. That is because of this. Let me show you with a drawing. So how if else conditions are evaluated is you have some code, some condition, and then you have if, and then you have something like elif, and then you have else. You can see that this is like you are going on a journey, and then you have crossroads there, and you have 3 ways to pick up. So this is how it evaluates if elif and else. So what if I want to do something like if this and also something here, one more condition. So in such cases, you can use a lot of if cases. If this is this, if this is this, if this is this, and things like that. And if you want to do some sort of crossroad sort of a logic, you use if, else if, and then finally else. So this is like a tree. And then if you want to add more conditions, so if you want to add one more if condition, you can keep on adding as many if conditions as you want. So it checks for all the conditions and keeps printing. Any questions in if else condition?
So the else
Yeah,
statement there, right?
yeah,
It works if it's opposite of if, but not for else if, right? I'm trying to understand in here, since
yeah.
this is the third step. So if x is not equal to 2, then only the else gets executed.
Correct. Yes. Yeah. Correct. This is based on this if. Correct.
Okay.
Okay. So that is if else if condition. And let us look at loops. So I'll show an example, real world example. You can try the programs. I'll give you some assignments so you can do that. You get hold of if else condition. Okay. I will delete this. Okay. So loops are nothing but repetitive tasks. For example, if I have to print from x to sorry from 0 to um, 10, I would, so if there were no loops, I would print something like x plus 1 and something like this, x plus 1, x plus 2, or even x is equal to x plus 1 and things like that. So but that's, oh, it has, you cannot keep on writing, right? So it's a repeated task, and this is just a very trivial example, just to understand the loop. So you can have loops for a lot of conditions, like to get a sum of all the numbers in a list or in any of this set or any iterable. So if you have something in a um, something like in list and tuple set, it is an iterable, but we call it as an iterable because you can count the elements inside that, iterate through the elements. And so loops are actually, we use loops in day-to-day situations. For example, let us just imagine that we have a piggy bank, and if you just imagine, how do we count the coin number of coins, or how do we count the total sum of the coins, from a piggy bank? And since we humans are um, sort of wired to, if you see number of, say, pens here, you don't have to count one, two, three. You can simply look at this and automatically see, oh, there are three pens here, because our visual capability is very good because of our counting and education. But the CPU or the program doesn't know, because it doesn't have automatic recognition, right? But now we have in artificial intelligence, but that is also a code. But if you want to think like an interpreter, like a compiler, you should think that you are blindfolded and you're trying to get instructions from somebody else, or you're trying to think through. So that is why you might see that when you want to think clearly, sometimes we close our eyes, because eyes is a distraction. So just remember that we already do this. So how do we count is like, okay, for example, I have coins of 2 and 5 and 1. So I would take those coins, keep it on the desk, and line it up, and then I'll take the first coin, so that I can segregate from one which is counted and one which is uncounted. Because if you start picking elements from the middle, you won't know where you started, right? So what you will do is you'll pick the first item and then segregate that. So mark it as done. So I have two, I'll write down two, and then so on. So ideally, you do something like this. So I will, the finger that is pointing to the first coin, there is a separator. So that coin, you can initialize that into, say, I, that is your, say, index finger, and then you initialize to the beginning of this list of elements. So once you line it up, you pick that up. So you say that, okay, I have initialized it to first position. First position in computer means 0th position. And then you start moving it. So start moving to next one. So your finger will be pointing here. And then I becomes 1 and so on. Till what? Till you get the last coin. So how do you know that you have reached the last coin? Because from you'll start searching for more coins. There are no coins, and now you know that it's an end of the loop. So we also have one more thing to condition, the thing to put into the condition. So one is initialization, one is ending. There is one more element which we do it automatically, but through computer we do it like this. So what we are trying to do automatically is that, like, we are trying to push out the coin to counted ones. So we are trying to move it out. So that this moving out and moving your hands from one coin to another coin is called as iteration. And you can also have condition for this iteration. For example, if you want to count only the coins which are of denomination of 5 rupees, which is like a thick coin, so you can, you know that, okay, if x is equal to something, so do this. Okay, you can have conditions as well. But for now, just let us just understand three things, which is initialization, ending, and then iteration. And hence in C, C++, how do we write in C, C++ is, so we write for loop like this: for I is equal to 0, and then I is lesser than some number, let us write it as n, and we say that I plus plus. Okay. In fact, this iteration, you can also, I plus plus is like moving in one direction, I minus minus, you can do I minus minus, you can do a lot of any operation, mathematical operation. But these are the three conditions from our operation, which is like we try to imagine coins, right? So we did initialization, ending condition, and iteration condition. So this is how we write in the C, C++ or Java and any language, other languages. So in object-oriented programming, what we try to do is, okay, now I have list of coins, which means I have, say, list in Python, or say object 1, object 2, object 3, and so on. And I pick up this element and do some operation. So since it's already an object, there are functions inbuilt to the language in Python, wherein we don't have to actually initialize like in C, C++. So here we are initializing here. So we don't have to initialize in Python. I'll show you that. And I just need to say from where till what. But since it is a list we have initialized, so the interpreter or the list already has a way to know the first element and the last element. So we don't even have to specify the ending condition for the data types that we have studied. And the iteration condition, which is like moving from one object to another object, this also we know. So how do you iterate from jump from one object to another object? For example, if this was an integer like 1, 2, and then say Python here. Okay. So if this was the list, but you cannot do it in C or C++ because an array should be initialized to, say, list of integers. But in Python, it's an object-oriented programming. So you can list cares about all of these are objects. Like 1 is an object, 2 is an object, even Python string is an object. So it knows that, okay, the type of this is integer. And in order to jump to this location, so we saw the memory map, right? So it's a grid. So if I have 1 here, to jump to 2, how many spaces should I jump, right? For example, in Python, the object integer has certain size. It is fixed. So I know how many houses or how many boxes I need to jump to get to second element, which is the next element in the list. So these things are already known. So now we know the initialization condition and we also know the ending condition. So how do you write the for loop in Python? Okay. So let me just jump to code. Let's get rid of this. I'll remove all of this. Okay. So let me initialize a list called as my list, and I'll start putting some uh, elements into this, various different types of elements, just to demonstrate what we studied right now. And I can also do something like 3.14. And let me put an empty dictionary here. And also let me put an empty set inside. So if it were C, C++, I would do something like I is equal to 0, and I would initialize I is equal to the beginning of my list. But we do not have to do it here. So I can simply say for I in my list and print I. So let me run this code. You can see that it has I've just pressed it twice, so we have two outputs. So 243.14 and things like that. So you can see that this is totally different from C, C++. You don't have to initialize, you don't have to tell where it ends. Because Python already knows this. So if you have to print only the numbers, you can have if condition. I can say that if type of this I is nothing but this, the in our example, it was like finger. So because we are counting it, this current element while counting the coins. So you get the coin, you print it. And if it is type of say 5, so there is another um, if I is equal to 5, let us look at this. Hopefully it prints error. So you can see that. So there is no 5 here. Add 5. So it prints 5 and it hits this condition, and then it comes out of this. So you can add like elif and write some condition. So difference between elif and else is like you can write condition. Else is like it doesn't have any condition, doesn't match any of this. It just come it's this if and else. Okay, so that is about the loops. So loops are um, being used in our day-to-day lives. Like we do not even care about it. So this is how we use the loops. Any question in loops, especially you're coming from different languages?
In this example, how many times it printed? If you remove if condition, so print I means how many times it will print? So take 2 times, 3 repetitive task or 1 repetitive task.
Sorry, how many times?
How many times? How we decide?
How many times this has appeared? Is it?
Correct.
Yeah. So yeah, for that you have to write your if condition. So that is one way to do it, but there are different ways. But you have to write if condition saying that, say, you have to initialize. So that is one assignment in your this one. So you need to keep track of certain numbers, right? So how do you keep track of certain numbers? Is like if I want to count like count of 2, I will do something like, okay, initialize this, and some if this I is equal to 2, I need to increment this number. It should be count, but yeah, is equal to count plus 1. And then finally, you can print two is print that variable which now has So you can say now there is only 1, 2. You can add this. Now we have count of it is 4. So that is how you. This is your control condition, which is if this particular item evaluates to 2, I is equal to 2. So count it. Like counting is nothing but like stacking up the coins. So this is your like count. So in our example that we looked at, counting is something like, so you'll have a paper. Okay, you'll have something to write. So once you counter 2, you can keep writing 2, 2, 2, 2, and then finally submit, or else you do what you do is, okay, I got 2 and another number is also 2. Now instead of storing 2, I'll just write 4 and another number is 2. Since it is paper, it is like visible on the paper, but we have another. Imagine there is a paper where you can write and erase. So now you have got 4 and then again you got 2. So you erase this and write 6. You look at 2, erase this again, and you count it to 8 and so on. So that is the paper or the box in the paper that this variable translates to. This is this. So was that your question?
Yeah.
Okay.
Digant, when do you use colon and when not to use colon? Sorry,
Oh, okay.
sorry if I missed that.
Yeah. So how does Python come to know that there is an indentation coming in? So in fact, there was a question to the Python creator. So why do you even need this colon when you have this particular spaces, right? This is redundant. But there are also conditions where you can simply use this. Let me clear this, get rid of this, where you can use this if x, and then in list comprehensions, you can do something like else something, else y if something like this. So you can in fact write it in one line as well. In fact, in Python, there is also, you can do something like this as well. So let me note this. So this condition can be written in one line in some conditions. We'll come to that. But so that is why we have colons. So colon means that there is a indentation coming in for the interpreter to remember. So that's the reason that we have colon. In fact, this was a discussion. So sometimes also people don't know much about the semicolon. Semicolon is supported in Python. So but it is not used for the same case like in C, C++. So it knows it separates the variables, but it is not very well used. But you have the support. Yeah. So the idea of the colon is to tell interpreter that there is a section coming in. So it looks
So
like
basically, whenever we have to use a indented
correct,
code
perfect.
followed, so before that we have to use. Okay,
Correct. Yeah, that's it. Yeah.
thank you.
Any questions? Like, it's just a concept like how to loop and how to do the conditions. Yeah. So that's it.
There is no putting end after every loop.
No, there is no end in
Oh,
the loop. In some
oh.
languages, like in basic, we have to put end. Like even in assembly language, we have end of some instruction, but here we don't have.
Okay.
Okay, great questions. Okay, that is about loop. And then, in fact, this was I wanted to cover yesterday. No problem. So yeah, so we wrote a program to count number of coins. So this is an exercise. In fact, you can try it right away, or you can try it later as well. But let us. Do you guys want to try it right away, or you'll try it later?
We will try it later as an assignment.
Okay, yeah. And if you have any questions, please send a screenshot on WhatsApp or just feel free to contact me anytime throughout the day. Okay, so now let us study. Okay, this is about if conditions and for loops, like looping and condition. So now we know how to control the program structure. Okay, so there, in fact, I can write this program and keep on writing like a shell script. Like I can add one more for loop, and then I can keep writing this like a script. So there will be cases where, for example, this particular logic that I have written, probably I want to use it to use it as a library function, which means that I can use it again and again, but somewhere else. So how do we do that? Is using functions. Functions are designed to extract some functionality, and then so that you can reuse again and again. The structure of the function is like this. We tell this is a function, for example, my fun, and we have this braces and we have this colon. So once you have this colon, we need to tell that this particular section, line number 1 to 7, belongs to this function, right? So how do we tell that? Is using the indentation. So once you have this indentation, now this is related to this function. Let us try to execute it and let us see the behavior, and I'll try to explain. You can see that nothing got printed here, which means you have defined the function, but we have not called the function. So how do you call a function is like this. Okay, so definition of function is by this def. So when you tell the compiler or the interpreter, Python interpreter, saying that def means we are trying to define something, and then it keeps in its memory, and then when you call specifically, it starts executing this code. So this is a function. So what are the characteristics of a function, right? So you can in fact pass arguments here. I can pass, say, list of numbers, which is just a variable, and I can pass as many variables I want, X, Y, Z, and things like that. And then if I pass something here, let us try to execute as is and see what happens. We can see that I got a type error. This type error tells that, hey, we are calling the function in line number 10. It says like this, we are calling the function in line number 10, which is leading to this particular error. And its definition is expecting 3 elements into the function, but you're not passing anything. So that is the error. And in order to fix this, you need to call it like this. And
Digant, these functions in Python are similar to methods in Java.
yes, yeah, the function, yes, correct, exactly.
Methods with different parameters. Okay.
Right, correct, yes, methods. Yeah. So in fact, you can also, while in some discussions, you can also hear people using methods instead of functions, which means the same thing.
Oh, yeah. Thank you.
Okay. So this is how you call the function. Okay. So any questions here? Function has a definition. It has arguments. And I'll also tell about something called as default arguments. So I'll show you. So sometimes we can also initialize a variable by default in a function. For example, so let me execute the same function again. It says it got executed because once I sent, I'll print XYZ. That will be more useful here. X, Y, and Z. This is XYZ 2, 3, 4. So let me just take out this 4 and show you how does it behave. You can see that we have 3 inputs or arguments for this function, but still I am able to pass only 2 of them. That is because we have initialized one of the variables as default arguments. So now Z is 0 by default. These are called default arguments. And another important thing in function is it can also have return values. So by default in Python, the return value is none, N-O-N-E. This is none. It is similar to null in C or C++ or in Java. So if you do not return anything, your compiler will throw an error saying that function is not returning anything or it is not defined what it returns. So if you have to do the same function, you'll do something like return me an integer, my function, and then write code like this in C, C++ or Java. But here in Python, we do not tell the type of the variable, it is automatically detected. So such languages which automatically detects your variables are called as dynamically typed. So because the Python interpreter goes line by line and it does not have to know its data type beforehand because it is an interpreter. So it goes line by line. Okay. So, okay. Any questions in default arguments? And okay, let me return some X. The reason that we have return function is because you can also store the values, say return value. Okay. Some variable is equal to return value. And then I can call the function. I store that return value into this. So let me just show you return value. So it just prints are coming from here. We are not printing return value here. Let's try to print return value. You can see that it is printing as none because we do not have any variable that we are trying to return. So let me return, say, C out. It should be count, but yeah, it's a spelling mistake. You can see that now return value prints 4. That is because we have returned some value out of this function. So these are the characteristics of the function. Function definition is done using a keyword called as def and write some variable, and then there are arguments, and then there are different scopes. Let me just talk about scopes inside a function. So in Python or in any language, so scope is nothing but, for example, let me show you here. So these are the variables that I'm trying to pass, right? So once it comes to this, so we have 3 different scopes here, or like for our visible eyes. So one scope is this. Scope is nothing but, you can think of it as a section in a long story. So it's like a small chapter. So once you get out of the chapter, that is no more relevant. Like there is a character, small character, and then there is one more character which runs through this entire scope, and probably the main character, hero, heroine, are probably bigger scope, like this. So there are 3 scopes here. So what do we mean by scope is that when we define a variable, any variable, so you can actually define a variable here within this block, small block, and that variable won't be visible to the outside of the scope. That is, we can call this as inner like scope, scope 3, and this is scope 1, and this is scope 2. So scope 1 is like main chapter, scope 2 is like another subchapter, scope 3 is like another chapter in that. So if you have any variables, it is only, if you have defined a new variable, it is only visible at S3. I'll show you that. And then if you define a variable here, it is visible here as well. And you can use this here. And if you have a variable here, you can use it in both of these chapters. So that is like a character. You can think like a, we have a movie, and then you have main character and you have some sub character, and there is also some character which we do not, which doesn't have much significance in the movie. Like, so you can think that, but of course this has significance in the code, but you can just imagine that it's a subchapter in the code.
Digant, one quick question. How we got like a return value as 4?
Return value as
Yeah, you printed like return value, print of return value, right? So we got 4, right? How we got 4?
okay. Let me just.
There are 4 twos. You are counting the twos.
Oh, okay. So whenever we, okay,
Okay.
got it.
Okay.
Yeah.
Forgot about the logic.
Okay.
Okay. Yes.
Yeah. Thank you.
We are trying to count the number of twos. Yeah.
Number of twos. Okay.
Okay. Clear about the scopes? I'll demonstrate that. Okay. So let me get rid of this.
Sorry, I just had another question. Why is it important to know the scope?
I'll show you right now. So for example, you can see that this, let me try to print see out here. You can see that in line number 14, we are trying to print this cout. So as we saw, this scope is completely not known. This variable is not known in this scope. This is only within the function. Within the function, we have defined a variable in line number 4. And this you can use within the inner scope, right? So here we have this variable cout, and this is visible from in this scope. So the bigger scope is this, that is the main function. So this is where your scope started, which is like a chapter. So this is a chapter, and within the chapter you have defined some variable which is actually visible inside your subchapters. So for loop, and then for loop is another chapter. It is visible here, and even under if there is another chapter, it is visible here, but it is not visible outside that function. So you cannot access that particular function. So that is what scoping means. So let us try to define one more variable.
So in this example, the scope ends at line number 10.
Yes.
For the count underscore 2.
Yeah,
Okay.
line number 9 actually. Yeah, correct.
Line number 9. Okay.
So in this example, cout.
It is similar to C++ scope operator, right?
Yes, correct. Yes. It is, the idea is similar. Programming is, regardless of the language, all these concepts remain the same. It's just
Is
that
there any symbol for scope operator in Python?
it is not specifically there. There is no operator as such, but I'll show you something. So you can, there are several scopes. One is local scope. Let me show you a variable, say in if. I'll show you here and try to print in. Okay. So you can actually define variables here, and then I can say let me get rid of this. Especially in if conditions, you can actually define variables because these variables are visible throughout the function. So for example, let me print I. You can play around with this. Let me print more a global, say. You can print G. You can see that I'm able to see this particular G here. So let me try to do something like I can alter this G to say 11, and let me print 11 here. G. You can, we got some error here. So it says that cannot access local variable associated with values. Okay. So in order to access this particular G, I need to tell that, hey, please use something from outer scope. So in order to use this, you can tell global G. So let me print. So you can see this address is retaining at all the places. But if you try to print, do the exercise like try to print these variables and try to access it. Of course, it won't. You won't be able to access out of this particular scope. But yeah, you won't be able to print that because the reason that this scoping works is because the functions are operated while execution is based on a stack. So there is that is why you see this sort of errors, for example, syntax error and things like that. So the function itself gets onto the stack. Once you get out of the function, it gets the stack, the top frame gets removed, and the next frame looks for this particular value, say C out, and it's not there. So that is the reason that you won't have that particular variable, so that it's out of scope. So that is one of the idea for scoping. So this scoping helps in terms of, say, you have a settings file where you have some global variables defined there, and you can import that into your current file and then start using that. And yeah, so this variable is visible here because it needs to be checked, right? So like that. So you can experiment in scoping, but it can also get complicated. So just remember that there is chapter and subchapter, and the scoping is like this. Like local scope, there is enclosing scope, which is like if the for loops and things like that, and there is the function also comes in the enclosing loop, and there is global scope, which is pertaining to that particular file. So global scope, and in order to make that variable operate on that top of that global variable, you need to tell the interpreter that, okay, this is a global variable, do not create a new variable for me. And then there are built-in scope. Built-in scope is nothing but we can simply use functions like, for example, print anywhere, right? Because I haven't defined print, I haven't defined def. There is a function called as id. All these keywords come under built-in scopes. So these are for scopes. So once you start doing your assignments, you'll learn about this, because you're going to like count the coins and things like that. You'll need variables like that. Okay, yeah. So any questions in function scopes? Okay, we are already 8 o'clock. Any questions?
Thank you, Digant.
Okay, yeah. Not joined. Okay, so do the quizzes and exercises. You'll get more, knowledge on this.